Now let's talk about the builder pattern. Hopefully the name gives you a hint on what it does. We're seeing the creational design pattern. So builder is a pattern that helps us build objects. So what is builder? So builder is a creational design pattern that is used to construct complex objects step by step. Here we have what? Builder separates the construction of a complex object from its representation. I'll say it again. Separates the construction of a complex object from its representation. Allows us to create different representations of an object while still using the same construction process. Useful. When is it used? So useful when dealing with objects that have many optional components or configuration parameters. Imagine a complex object that requires several fields or properties. What do we typically do? We create a huge constructor or multiple constructors. So builder is going to help us address that situation. Instead of using many constructors or telescoping constructors, we're going to have a special building strategy. What are the elements and characteristics of the builder pattern? So sometimes you have the builder interface. There's an interface defining set of methods for building the different parts of a complex object. Concrete builders, classes that implement methods defined in the interface. They construct, they build a particular representation of the complex object. Each concrete builder may provide a different way of assembling the object. So there's some variations of the builder pattern we might see. One of them is the builder with director. So we're going to see the simple builder and the builder with director. So the director is responsible for orchestrating the construction of a complex object. So orchestrating, for directing the construction steps of an object. It works with a builder to build the object step by step. So builder, creating an object step by step, determines the order in which to call the builder's methods to create the final object. So that's the nice thing about the director. So if there's a step-by-step predefined, which the order is important, we can use the director. Product, which is the object that is actually constructed. So the object we want in the end. Usually contains many components, attributes, or configuration settings. So again, it's just going to be the object we want to build in the end. Key points, I will do this later on. We're going to see the diagram and code in the IDE. Here we have the telescoping example first, which is the bad example. So if we go to the telescoping constructor sample, here we have, hopefully the zoom is not distorting it that much. You're used to this by now. This is a UML. Here's a representation of a class, person class more specifically. Here you have the private attributes. Here you have a bunch of methods, the getters and setters. You have a toString down here. And then you see the list of constructors. Look at how many. Oh my god, this is a little bit ugly. So you see there's lots of different types of constructors here. So let's take a look at the code and see if this makes sense. So the person package, there's a person class. What do we have here? So we have person class with all its attributes, our beautiful getters and setters, our beautiful toString method. Then down here we do have the telescoping constructors. So what are we doing here? What are we doing here? So first we have the initial constructor, passing all the arguments, the list, initializing the values of person. But let's say we have an optional field. We don't have that field. Let's say the email address. We have another constructor that we have to then call the initial constructor. So this, which calls this constructor here, is doing what? Person ID, first name, last name, phone. But I'm not giving the email here. But I have to pass null, because in the end I'm calling this constructor signature here. Same thing goes if we're going down the chain. We don't have phone, but you still have to give a null value. We don't have last name, you still have to give null. First name, so we have to give null. Last but not least, no arguments, so we're initializing to default values. What if you add a new property here? We're gonna have to do some changes, right? We're gonna have to play with our constructor, so not that interesting. So let's say we have to add, what are we missing here? Address. So if we add address, I'm gonna have to add one extra property here. In all of them. This is gonna makes our life a little bit difficult. Builder is gonna help us address this major issue. So let's go to the test class or runner class. Too much zoom. Here, we're used to do this by now, right? So what are we doing here? Person A, so just a variable, bad naming though. Instantiating new person with the ID, the first name, last name, phone, email. Then we're going to create another object, but this time the phone number is an optional field. Let's think about the logging process again. Typically when creating an account in any website, typically you provide first name, last name, email address, password, but the phone number is optional. Since we have phone right in the middle of the list of arguments, if we don't have the phone number, we have to explicitly give an empty value, right? Or null value. So if I just get rid of the null value, this becomes the phone. It's wrong. This is not the phone, but I still have to pass it in the argument list. And that would be the case for any other optional fields. If we right click and run this file, you can see first name, last name, phone number, email address. Then for the other object, we have first and last name, phone number being null, and the email address. So let's apply the builder pattern here. Let's make it a little bit more maintainable, let's say. So I will minimize this, close those two. Let's go to builder simple. So source, I'll open up the diagrams first. So the diagram is a little bit different. So here we have person builder launcher, which is going to have our main method. Then we have the person class, looks the same. No, almost there. So properties are the same. You have getters, you have setters. Okay, this is all typical. But look at our constructor. We don't have that giant list of constructor anymore. Now we just have one constructor that takes one type of argument. What is that new type we're seeing? Person builder. Remember, where is my slide? This one. Look what we have here. One more. Construction separates the construction of a complex object. So look what we have here. Separate the construction of a complex object from its representation. So we're taking away the building steps from those constructors and putting it somewhere else. So we took the constructors, we put the responsibility for building the object somewhere else. That somewhere else being our person builder class. This is one of the downsides of it, although it's useful, which is we have to duplicate the properties. So person builder, you see that it's the exact same duplicate of the properties from person. You have the getters, so getter, get person, get first name, last name, phone, email. Look what we have here. A personal constructor of that class. So it means that only this class is going to instantiate it. Then we have the create method, which is the exposed method that allows us to return a person builder instance. And then we're going to have different methods here. One per property, returning what? The same instance that invoked itself. So here we have person ID returning a person builder. So it returns itself and it's going to allow us to chain those methods. So if you have something that is optional, you just don't invoke the method. Then at the end, okay, after you model it up, you got all the pieces you want, what do? We build the person. What do we build here? Build returning person. So this is going to invoke the new person constructor that has the person builder. So we put all the information, so we put the person ID, the first name, inside the person builder object. Then we pass that object into this build method. Let's see it in code. Let's see if it makes sense. Here you have sequence diagram. I'll let you play with it after. So here, let's go to person builder launcher first. What do we have here? Slightly different code. Right click and run. It's going to give us the same output. First name, last name, phone number, email address. Then we have an empty first name, last name, empty phone, and email address. But what are we doing? So person A, bad variable name though, receives something. What is that? Not new person with a bunch of arguments anymore. Here we have person builder dot create. Okay, so it seems like it's a static method. Then we're chaining all the properties that we want. If it's optional, we just don't invoke the method. So person builder dot create creates the person builder for us. Then in that person builder, so this person builder, let's add each property. So dot person ID, give the ID. Chain the first name, give it the first name. Chain the last name, give it the last name. Chain phone, chain email, and so forth, so on, until the last step. Say, okay, I have all the properties. Now we finally build that person object. Same thing is going to be for person B. So person builder dot create creates an instance of person builder. Then add up the information that we have. And finally, okay, I have everything. Then you build the actual person we are interested in. Let's see person first. So if we go to person, similar code. We have the properties as the previous example. Getters and setters, to string, but then we just have one constructor now. So public person takes one argument. What is it? Person builder. So the person builder we're going to create. So let's go to person builder and look here what happens. So from that builder object, give me the person ID, give me the first name, last name, all the properties, and you assign it to the person corresponding properties. So if we go control person builder, what do we have here? So our builder is going to be responsible for building the object, instantiating the object. Here we have the properties. We did notice that we did add the address here, so you can ignore it for the example. So you have the properties. You have the getters. No setters yet. Look at this, the private constructor we've seen from the UML. I can even open it up to correspond it. So private instances. Then you have the getters. Private constructor here, person builder. Then you have the static method returning a person builder that is used for creating a new person builder. So we're going to create instances of person builder. And then we have those, let's call them special setters, just for example purposes. So those special setters, they're not only setting the values, right? So ignore this return type for now. So here we have person ID receives an argument. So to the person ID in the person builder, assign the value that we got. And then of course, we're going to return this instance. So the instance that got invoked. Here's the type, the return type. So we see person builder, it's going to return the instance of person builder. This is what allows us, all those returns here is what allows us to chain those methods we've seen here in main. So this is a person builder, right? So person builder.create. Person builder.create is this one. Returns a new person builder. So it means that in this block, This is a person builder. I can invoke any methods of that class, any public methods at least from that class. So what methods do I have? I have the getters and I have the special setters. So I can call directly here dot person ID 1. Then I just pass the argument dot 1. And now this method person ID also returns what? This, which is person builder. So it means that I can invoke any methods from person builder. So everything here is a person builder. So I can invoke, I can just chain the methods. I can say dot, whatever method I want to call. Okay? If it makes it easier to visualize, you can separate it. Person builder equals to this piece here. So this is a person builder, right? This is okay. And of course we have to say builder here. So to that builder that we just created, add up the properties. I can even remove this piece here, the person, and put it here, right? Because everything here is a person builder. So it means that I can put it in this little variable here. And then I just add new methods. I just call new methods. Okay? You can do this just for visualization to help, but typically you're going to see it as a chain version. So it goes all the way down for all the new properties. What's the bad thing that I told you about this? If we add new properties, as I mentioned, the address, we have to add the address here. We have to add the address here in the person builder. Of course, you're going to have to add it in the person as well. So there's a little bit of extra work and some duplicate code. Okay, last part was, so we add all the properties we want, but we're not interested in the person builder. We want the actual person. So we have to call the method build in the end from the person builder, which is doing what? So the build method returns a person. What does that method do? Return a new person. Okay, so it's going to instantiate a new person, passing one argument. What is it? The instance that was invoked. So the instance, all of this that was invoked, that has all the property values. Then you build the person, you put it here. If we get rid of the build method here, this is returning a person builder. So it's actually incorrect. We want a person. Love it. And this is a simple builder. Not that simple, right? So I did show you the person. I did show you the person builder, showed you the diagrams. So let's go to the director one. So I can right click and close all of this. Builder director. Clear this. What do we have in the director? This is a little bit different. Look, we have that interface that we mentioned in the slides. We do have a car. We do have a motorcycle. It's always the car's example, right? And the director that's going to know the building steps. Look what we have at the interface here. So the iBuilder interface has build body, insert the wheels, add headlights. So the steps for building the objects. And then in the end, get vehicle, the one that gets the product. Remember the product being the classes that we want in the end. Here, of course, you have the type product being represented. So I will close this. Let's go to code. So builder pattern example. Right click, run the file. What do we have? So builder pattern demo. First we have product completed as below. This is a body of a car. So 4 wheels, 2 headlights. Then we have another product, motorcycle, 2 wheels, 1 headlight. So what actually happens here? So first print, then we instantiate the director class. Okay. Let's see the director already. What does the director do? So the director has a reference to the iBuilder interface. And then series of steps for the production. So the director knows how to build based on the builder interface. Notice that this is the interface. It means that I can send as an argument any class that implements that interface. So from the build method, what do we do? So to my builder reference, I assign the builder that I sent, and then I'm going to invoke the actual construction steps, the building steps of those classes. So from my builder, I'll build the body. From my builder, insert the wheels. If it's the car, if it's the motorcycle, as long as it's from iBuilder, we're good to go. Then what do we have? So a reference to iBuilder, we're going to start with the car. Car builder takes an instance of new car. Let's go to iBuilder. What happens in iBuilder? So just the interface defining the creation methods. So we have build body, insert wheels, add headlights, and at the end, a representation of vehicle. So get vehicle returns product. What is product, you might ask? Let's take a look. So product is just a class representing a data structure for vehicle parts. We could have a different name here, but we're using a linked list of parts. Okay, we're representing parts as a linked list, better saying. So when we instantiate product, what do we have? So just initialize parts. In the product class, since we have this list of parts, we add new parts, right? So add string any parts you want to add at the end. So to the linked list parts, add at the last element the part that we're giving. And you have the show method. So product completed as below. Oh, this is from here. You got it, eh? So we're just looping through the parts and printing each part that is there. Okay? I'll close the product. I'll close the builder. And we're going to go to the actual car at this time. So let's go to car. Remember I told you, as long as the class implements iBuilder, I can pass it in the build method of the director class. So director, going again, has the build method taking an iBuilder interface reference. Car is a type of iBuilder. Let's call it that way. So the director invokes the build method. I can give car. If the car does not implement the iBuilder, first it's already complaining with us right here. Car cannot be converted to iBuilder. So let's put it back and save. So no errors. Looking better. The error is still there, but there you go. Refreshed. So let's go to car. What does car have? So the car class has a representation of product right here. Remember that product is our list of parts. Of course, we're overriding the methods from the interface. So how do we build the body of a car? To my product class, I'm going to add a new part. So I add parts to this representation here. Insert wheels. How do we model wheels of a car? So to the product list, I'm going to add this parts here, which is the 4 wheels. Then same thing for the headlights. To the product list, I'm going to add this part right here. And at the end, what do we have? Return what? The product. Return the information about the parts of that vehicle. So back to the director. What do we have here? The list of steps to build the product. So each method call is going to add to that product list. Then we're able to product P1 receives from the car builder, I call get vehicle. So again, car builder dot get vehicle. This takes us to the interface. It's going to return product. So from car, so the car builder get the vehicle, return the product, which is the class representation that has a data structure to store our parts. What happens for the motorcycle? Same idea. The builder, the director knows the steps to be able to build a motorcycle object. So motorcycle iBuilder, we instantiate the motorcycle building class. So if we go there, motorcycle implements the builder. What do we do next? Oh, same thing as the car, right? A data structure to represent the list of parts. So this is the product class. If you go inside, you will see the exact same thing as the one we've seen for the car. Build the body. So to that list, so to that product class, to that reference, we're going to invoke the add method, which allows us to add the parts. Same thing for the wheels, same thing for the headlights. And at the end, we have the get vehicle, which returns the product class, or the product instance. So back here, what do we have? Director.build for the car. We retrieve the vehicle from the car builder, the vehicle representation, better saying. So from that product, please display. What does P1.show has? Already shown you this. Product completed as below. Loop through the list and display each part. So product completed as below, we've seen this. This is the body of a car, which was the first text. So body of a car, then the 4 wheels, then the headlights. Same idea for the motorcycle. So from the director knows how to build, but you have to say what, right? So the director knows the steps to build. What do you want to build? Oh, a motorcycle. So if we go to the director class again, I'm just repeating myself at this time. We have the build method taking an iBuilder reference, knows the steps, so one step at a time. From the motor builder, we're going to retrieve the instance of product, which is our representation of parts, assign it to the variable P2 of type product, and then we display. So when we show, come on, there you go. The show method, product completed as below, and it displays, it loops through the list of parts. Love it. Now you visualize this, the iBuilder interface being implemented by car, being implemented by motorcycle. And the director uses iBuilder. It has a reference to that iBuilder interface. Now we can go back to this one. So we did talk about the elements, diagrams, key points. So step-by-step construction. Did talk about it a lot of times. So step-by-step construction allows us to create the complex objects incrementally or step-by-step. I'm not going to give any magic numbers. I'm not going to say from 5 class properties on, we're going to use builder. Not necessarily. How complex is the object? That's going to take a design decision. Separation of concerns. Interesting. So separates the construction process. Let's call it the constructors from the representation of the object. So where you instantiate the object, it's somewhere else. The separation makes it easy to create different representations of the same object. That's the chaining methods of the builder pattern. Fluent interface, so builders often use a fluent interface. Allows you to chain the method calls, making the construction more readable. In different products, so implementing different concrete builders, we can create a variety of products, as we've seen in the car, as we've seen in the motorcycle. Here we have a simple example, a simple exercise that I would like we to practice. I'm gonna leave the sample code available. You do it first, then you check with the sample code as a practice for the builder simple. Here we have to create a house. Then we go for the director, and we're gonna create a program for construction company. Okay? I'll let you play with this later on. So we can pause the video, do the exercise, then you check with the proposed solution. That was it for Builder. I hope you enjoyed it. Let me know if you do have any questions. See you in the next one.